My pleasure to introduce Dr. Brent Clothier, Science Group Leader, Systems Modelling, New Zealand Institute for Plant and Food Research Limited. Welcome, Doctor.
Tēnā koutou, tēnā koutou, tēnā koutou katoa. Greetings from New Zealand. I was last in Griffith 33 years ago. I was a young postdoc student with CSIRO in Canberra and visited here. It's great to see the city really going ahead. Also, I'm very pleased with the title of the topic of this conference, Sharing Knowledge for Better Outcomes. So I'd like to give you a perspective from across the Tasman of what we've been doing around irrigation, and maybe you can see some advantages and disadvantages in what we're doing as I can see it from here. When we start looking at water, there's a new dynamic emerging, and that's the dynamic of the supermarkets, and it affects the New Zealand industries, in particular our horticultural industries that I work for. Supermarkets are the gatekeepers. They're controlling a lot of our purchasing activities, and so they're asking the suppliers about their water footprint, amongst other things like their carbon footprint. So Walmart have set up a sustainability product index, and they ask all their suppliers 15 questions. 2 of them relate to water. Please report how much water is in the product you're about to sell to us. And have you set a publicly available water reduction target? Many supermarkets are doing these kind of questions to the suppliers to compete against themselves, but the NGOs such as Greenpeace, the Worldwide Fund for Nature, are the dynamic behind the supermarkets doing these kind of things. So it is quite a virtuous circle, but it's something that we, the irrigation, the producers of food from irrigation, need to be cognizant of. And so when we look at how much water is in our products, according to the FAO and the Water Footprint Network, it seems there's heaps. I'm going to talk about a glass of wine. It seems, according to the FAO, that it takes 120 litres to make a glass of wine. Now, I want to cast some scientific scrutiny over those figures. So what we've been doing, we've just had a look at what is the water footprint of a bottle of wine grown in New Zealand's Marlborough region. No doubt it's a Sauvignon Blanc, and it's not the red wine in the bottle at the bottom there, but that's the only one I could find. So when you have a look at how much water's in a bottle of wine, you have to consider the whole system. You have to consider what's in the system itself, from the vineyard through to the winery, and also what comes in from the background system. So we did the full life cycle assessment of how much water is in that cradle to winery gate. So when you talk about water, the Water Footprint Network talks about 3 water colours. Green water. The stuff that falls out of the sky is stored in the soil or drains to groundwater. And if that runs out, you go to the blue water resources of our rivers, streams, lakes and aquifers and take it out to irrigate. That's why we're here. And there's another colour, and that's the grey water footprint. What is the changed water quality of the leachate quitting the bottom of the root zone, and how much water would you need to add to that to bring it up to an acceptable standard? So we think that's a reasonable assessment of the water colours, but we want to cast some scientific scrutiny over those. And this is what the Water Footprint Network does. It has a look at the direct water use, the indirect water use, and the 3 water colours here, and they say there's a return flow here. And I want to focus on that because they stick it outside the box. So this is what they do when you draw it diagrammatically. They do a mass balance and the water goes in and out, but they actually don't care about the stuff that goes out. That's lost. So when we do their calculations for a bottle of Marlborough wine, we come to these numbers. We have the blue water and the green water. I'll ignore the grey water for now and I'll come back to it. So we think, according to their calculations, we think it's about 740 litres for a bottle of wine. Whoop-de-doo, it comes out to 124 litres per glass. So we're not too far away from what they said. But we think they're only telling half the story, because all they're doing is considering how much water goes to the atmosphere. And as a physical scientist and a hydrologist, that's only half the story, because there's a very, very interesting half that begins in the root zone. And that's the stuff that goes down. Because there is a connection between evapotranspiration, rainfall, and drainage. And that drainage of water is not lost. It's a vital environmental flow. It connects our surface waters to our groundwaters. So we think you need to put the full hydrology in any calculation you're doing about water footprinting. So it gets a bit messier, but that's all right. We can handle it. We need to consider the blue water resource. There's the green water resource. Stuff runs off and will eventually enter into the blue water resource. And you take blue water resource out of here and irrigate, or in certain circumstances, frostfight. In certain areas of horticulture, we do a lot of frostfighting with water. So we consider the mass balance of that groundwater resource, because there's both inflows and outflows. So when we do those calculations across Marlborough, surprise, surprise, on average we get a negative number. Well, if you have a positive number, that means a negative impact, and if you have a negative number, it means a positive impact. For every kilogram of grapes harvested in Marlborough, New Zealand, there is 85 litres of water contributed to groundwater. So that's an incredibly positive thing. Under the vineyards, the groundwater resources are actually being recharged by that. You take the net out from the evapotranspiration, the stuff that comes in by rain, and you can see it is dependent on rain, and this is a regionally production weighted average. So there's 85 litres of water going back to the environment under the vineyards. So when you do the calculation and take some of the stuff out from the background system, there is water consumed because we use water to make electricity, of course, and I won't go into the detail there, but we have to add that, and there's also water used in the winery. But on average, for every bottle of wine, the Marlborough ecosystem has received 66.8 litres of water. So that is a very good thing for the environment. It's not 120 litres per glass. It's actually 67 litres contributed to the environment for every bottle of wine. So what's it going to look like in the future? I'll come back to that a little bit about greenwash and how you relate that to Mr. and Mrs. Walmart. When we look at climate change predictions for the end of this century, it's not actually that a pretty story, especially for the horticultural regions of the world. When you look at California, Central America, Chile, Argentina, South Africa, Australia, especially the wheat belt in Australia, but in particular the MENA countries, the Middle East, North Africa. So we're going to have to be a hell of a lot smarter what we do with our water when we're facing the spectre of climate change. And so we've had a look in a recent project about what will happen to the water needs in the region of Marlborough for vineyards. And we've considered it for two scenarios, a really bad one, the A2 scenario, which we're tracking on now, unfortunately, or a more gentle scenario, this one here. And we've centered our calculations on 2050 to see what are we going to need for water in 2050. And indeed, we're going to need more, especially in the Marlborough region. And of course, here is the average as a function of how much water is held in the soil. So these are very bony, coarse soils. They need a lot of water on average. But of course, you don't irrigate water on average, because that would mean you'd end up with not enough water in half the years. So most of the regulatory authorities in New Zealand allocate irrigation water on an 80% probability. So they will meet demands 8 years out of 10. So that's that top bar there. And you can see with climate change, we're going to be getting something in the order of 30 to 40 more millimetres per year required, depending on the soil. And so we're going to have to be smarter than what we are now with the water that we're going to need in the future. There's another thing. I don't know whether you get the National Geographic, but there was a very, very interesting article in the National Geographic, and this is a big driver of concern in New Zealand, about fertiliser use. and irrigation is affected by this too. And this is what the National Geographic says: if we don't watch out, agriculture could destroy our planet. Very, very interesting read in a popular magazine like that about what we're doing with the nitrogen on the world. That's a photo of Lake Erie, by the way, in 2011, where 1/3 of the surface area of Lake Erie was covered by that algae. So some very, very interesting pressures coming on us through that leachate. I said the leachate in Marlborough means that for every bottle of wine, about 68 litres goes to groundwater. But if that 68 litres of groundwater is full of nitrogen, that's not such a good thing for the ecosystem. So the Water Footprint Network also have a means of calculating that. They take it by saying, how much water would you need to dilute the leachate to bring it to an acceptable standard? So for groundwater, we took the drinking water standard, because every New Zealander drinks 2 litres of groundwater a day, so I understand. And so we use these calculations, and indeed when we calculate it for the Marlborough vineyards in terms of the nitrate leaching out the bottom, you would have to take 44 litres of water to dilute that down. But I don't know whether this is a very useful metric, because you see, you're dividing by the yield, because it's a bottle of wine. And so you could increase the efficiency of your production by producing more, but maintaining the same leachate load, and you would reduce your footprint. But your environmental impact would be the same. So I don't think the Water Footprint Network has got it right here either, in terms of having a metric around a water footprint, the grey water footprint, where you're dividing by yield. I think it's not a good driver for change. We need to go back to just our standard common all garden understanding of what the concentration is in the leachate, and the leachate load in Marlborough is half the drinking water standard, so that's not a bad thing. Or we can put that into a loading in terms of kilograms of nitrogen per hectare per year, and we can give that to the geohydrologists, and they can put it in their models to understand the ecological impacts of that loading. So I think we have to go back to standard metrics and not worry too much about these fancy footprint ideas. So what we're doing to dispel these ideas of greenwash, and we've done this for the pip fruit industry, is provide a calculator that growers could use if Mr. or Mrs. Walmart come and knock on their door and ask them for what their water footprint is, so that they can put in information of where they grow, what they're growing, and come through and provide them with an answer. And so it's based on good hydrology, and it provides an answer that it relates to the specific orchard or vineyard. It was interesting to hear about the augmented storage, and this is a big thing happening in New Zealand. The government has a business growth agenda, and one of the planks of the business growth agenda is to increase our exports. And of course, New Zealand's an agricultural country. We don't dig holes and send them to China. We have to grow things and send them to China. And so there's a $400 million irrigation acceleration fund in New Zealand. And one of the first cabs off the rank is in the Central Hawke's Bay over here. And it's a flat internal basin that goes into the hill country here, where a 90-metre high dam is proposed to irrigate these zones down here, using the river as the conduit for that storage. And so this proposal is underway. We have been involved in that. One of the interesting things about this basin is there's no groundwater egress. There's a line of hills here that stop it. And so all groundwater re-enters the river here or here. And so anything that you do in that basin with irrigation will impact on very short-lived groundwater that will re-enter right by two towns here and flow down towards Napier. So there was a great concern about that in terms of leachate loading. The water story is quite good, because there's a ton of water, and it's always going to rain in these hills, and there's a good supply that could lead to a transformation of the landscape of the Central Hawke's Bay, the Ruataniwha Plains. So we've been doing some work about measuring leachate loads. We don't only model them, we also measure them. So we've developed these tools that we can bury in the soil. They're like buried rain gauges. And you bury them in the soil, and they mimic the unsaturated conditions in the soil. And you can see this is under a dairy farm. And very high variability, because you never know when you're going to have a dump of cow's urine land on one of top of your instruments. If it doesn't happen today, it's probably going to happen next month, and eventually you end up with very, very high variability. But we can measure what's going out the bottom of the root zone. We can model what's going out the bottom of the root zone. So that's the key factor, that we do know what's going on in the root zone, and we can predict what's happening. So when we go into the Ruataniwha Basin, we can take the landscape, we can take the climate, we can take the soils, we can take the existing farming types and put them all together, and then we can put them into our modelling system. That's where we come in here, doing the night shift, and we can model those to look at the outcome in terms of the whole basin, and then we can give that information to the geohydrologist, and they can tell us what it will mean in the river here and the river there. So this project has been underway for about 2 years, and we've done that. So we've taken the status quo and said, this is what the landscape looks like now, and across that patchwork we've modelled the flows under the existing land uses, and the geohydrologists have taken our results and matched it to see what they can find in the river. The Tuki Tuki at Waipukurau is one of those exit rivers in terms of nitrogen and in terms of phosphorus. The phosphorus is quite low because it's a flat landscape and there's not much sediment getting into the river, and phosphorus tends not to move. The nutrient of concern is, of course, the nitrogen. So we can validate our model on the current landscape. And then we can take future scenarios and say, what would a mosaic of irrigation possibly look like if we went into this landscape given its soils? And we can then take that and then model what the impact will be on the river. Very little impact on the phosphorus, some impact on the nitrogen. So that's where we're at now. Where to? We've looked at the mitigation options, how we might be able to get that curve down to the existing level. There are two options where we might go. Might we go to the Environment Court where the community won't agree? That's a high probability. But we're having some success more recently. We're developing an accord between the community groups in basins where they can see the economic benefits and accept the trade-offs that do occur. So I hope we end up with the third one, not the second one, having been through a couple of second ones previously. So how can we better use our water? And I'll just conclude with some of the stuff that we're doing now around tools that can be used on farm, on orchard, to maximise the value from the use of our irrigation water and minimise the wastage and nutrient losses. And so we've developed through a project with a whole range of horticultural industries, a decision support tool called Crop IR Log that's web-based. So our target are the consultants who carry out the irrigation management on behalf of the growers. We've got tools for measuring water use. We put little things in trees and we can see how fast the sap is moving up the tree, so we can work out exactly how much water the trees are using in litres per hour, depending on how much water is in their root zone. With horticultural crops, you have a problem because they're very complicated canopies. You have to know how many leaves are on the tree because it's the number of leaves that drive the water. So we put out light arrays, and we have a very good understanding of how the shadow grows during the year, how the leaf area develops, and we can relate that to the number of leaves there are. We can relate that then to how much water is going up the pipe, and we can put that into our model. So here are some grapes, and so you can see bud break, the grapes going up. Pretty flat over here because there's a lot of leaf plucking and pruning and hedging goes on with grapes. And then you can see as the season dies down and the leaves fall off, the water use goes back. So we have a very good understanding of how much water on a daily basis in relation to the prevailing weather horticultural crops use. Pastoral crops are reasonably simple to do because they don't have the complexity of the leaf area and the canopy structures. So we can then put that into a real-time web calculator for irrigation that's available for the consultants or the growers if they're really interested. and that provides a tool where they can set up an irrigation strategy. In grapes, you want to hold the water, the green line, you want to hold the water at a strategy to flowering, and then pull it down to veraison, and after veraison, put on some deficit. You can have tools in there measuring the water content, tracking how your irrigation strategy is going, and so you can monitor your irrigation through the year. This also is a very good tool, again, for Mr. and Mrs. Walmart, because if they ask you how much water you've used, it's there, and you can show them how through the season that water has been used. So they're the kind of tools that we're developing for growers. I've showed you the tools we've developed for the regulators. So I'd just like to conclude. It was interesting, Brett, that you said that Bill Gates said we have a food crisis. Well, The Economist in 2008 said, no, we don't. We actually have a water crisis. Finding water to grow the food is going to be the big problem. We're doing pretty well. Thanks to irrigation, we can produce 40% of the world's food and fibre from just 17% of our lands. But through the challenges of climate change and population growth, nonetheless, we're still going to have to do better. We're still going to have to do more from less. Thank you.